Hello and welcome CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and the following video tutorial is going to be on challenge activity number 9. And as you would anticipate, we're going to be working with policy-based routing as well as IP SLA. As you can see, we have our topology here over on the right hand side. Let me get desk scribble up here. It crashed a little earlier. So we have our topology over on the right hand side, and what we're going to be doing is we're going to, and I'll pull the scenario up here in a second, we're actually going to be taking a look at taking all of the traffic from this segment here, and this is the 192.168.110.0, and I believe it's a /24. So that's this network here, and this is our .1 default gateway. We're going to force the traffic with policy-based routing to come off of the segment, and then it's currently going through the WAN link, right? And I'll change this to green, and this is the direction that we're going to make it go. So we don't want it to go over the WAN link anymore, and that's the route that it's currently taking. We want it to go over the serial link here along the bottom between serial 20 and serial 10. Let me make that a little smaller. There we go. All right, so that is the plan, and we're also going to check, or what I should say is we're going to verify availability. And that's going to be the statement that we put in our route map when we get down to the IP service level agreement. Okay, so let's go ahead and dive in. We know that we're going to grab all web traffic. The scenario, if I pull it up here, does not say whether or not it's HTTP or HTTPS, so we're going to assume both. Now, one of the difficulties here is they have us dealing with www traffic. And as you've probably noticed in the diagram here, there is no web server over here. So there's really no way for us to do any kind of a there's really no opportunity for us to do any kind of a validation with the web traffic to see that the web traffic is actually going that direction. So let's go ahead, dive in here. We're going to jump into branch router 1, and we'll go from user exec to privilege exec. And let's just go ahead and say show IP interface brief and take a quick look here. So you can see that we were going to want traffic to go to that 10.10.20 network that runs across the bottom. And right now it's going to the 10.10.10 out to the WAN. And there's our 192.168.110.1. Okay, so let's go ahead. We know the traffic we want. So let's go into global config, and we're going to create our extended access list. So I'm going to say IP access list extended, and let's just name it www. And that'll be a pretty easy one to remember. So now, what would I like to do? Well, usually you should put a remark in here, right? So, and I like to highlight mine with a couple of asterisks and say ACL to match all www from the 192.168.110.0/24 net. All right, so we get a comment in there, and now this is pretty straightforward. We're simply going to say, and I like to start, I usually go in increments of 5. So for my sequence number, I'll say 5, and then just permit TCP from any host going to any host equal to port 80. And then let's also go ahead and grab 443. Oops, sorry, got the duplicate sequence number there. So let's jump this to 10. All right, so if I say do show IP access list, so there's our access list. If I were to put the name of the access list in, we don't get much other information other than, in fact, it's identical. So we're going to see the same thing. So we're grabbing www and we're grabbing 443. If I were to say do show run, and we want to see the comment that we've placed in the ACL, we see it in the do show run. You'll notice we did not see it when we list out the ACL, right? So we see it inside of the running config. Okay, so that's the ACL. So that's really I like to say 1B, right? 1A is trying to identify, because again, PBR is source-based routing. When we're using policy-based routing, we're routing the traffic based off the source address, as opposed to based off the destination address. So now that we've got 1A done, which is identifying where the traffic is going to be coming from, where are we sourcing it from, it's going to be that 192.168.110. What we're going to do now is we're going to do, well, we just did step 1B, is we create the ACL to match that traffic. Now that we've got the ACL created, let's do our route map. So I'm simply going to say route map, and I'll just call it rm_www, and we're going to permit 10, right? So we want the first statement, if it matches, to allow the traffic through. So we're going to say match IP address. Now remember here, you don't want to say prefix list, because we're not using a prefix list. So we want the word or simply the name of the ACL. So if I match the ACL, right, or whatever traffic is matched inside that ACL, I'm going to set the IP next hop to 10.10.20.1. And then I'm simply going to type in exit. All right, we've got the route map created. Let me take a look again. I think we need to look at the job aid serial 10. It should be 10.10.21. There it is. So we're going to set the next hop IP to 10.10.21, and the interface is Ethernet 02. All right, so let's jump into interface Ethernet 02, where we're going to use that IP policy route map statement, right? It's not IP access group, right? It's IP policy route map, and then the name of my route map is just simply rm_www. All right, so now that we've added that in there, remember what we said is that we also want to make sure that the interface is actually up and operational, right? Because this is going to be critical to make sure that that the interface, because PBR is static. So if for whatever reason this interface that we are now pushing the traffic to right here, if this interface were to go down for some reason, PBR is static and won't know any better. So it will keep sending the traffic over here to serial 10. And obviously, that would end up being a problem, right? Because the interface would be down. PBR being static is not going to know any better. And so then what is it going to do? You've got it. It's going to continue to send the traffic. It's just going to continue to send the traffic to the headquarters router over that serial 20 interface. And that's not what we want, right? That's definitely not what we want. So let's do this. We've got the www traffic. Let me clear the screen here. I'm trying to think as I'm typing this in, if we add in another statement into that ACL, just so we can validate, so we're matching the www traffic, the web traffic, 80 and 443, and let's jump back into that ACL here. So I'm going to say IP access list extended www, sorry, and I'm going to go ahead and on, let's see, statement, we'll do 15. I'm going to permit we'll do IP host. IP host 192.168.110.10. And going anywhere. I'm going to add this statement in. And what this statement's going to match, right? It's going to permit, and I'm really looking, it's more of a match than a permit. So I want to match IP, which is everything, right? TCP, UDP, everything from host 192.168.110.10, and this is, I believe, this is the laptop, and going to anywhere. So basically what I'm doing here is all traffic coming from the laptop is going to be subject to this policy based around this PBR configuration that we have, because I'd really like to be able to show on the notebook here, if I were to say go from user exec to privilege exec, whoops, and let's check our PC here real quick and see show IP interface brief. The PC is 192.168.110.20. The notebook is still Control-Shift-6 won't get me out of it. So we have the domain lookup, as you can see here, it wasn't disabled. And so we are now subject to the Cisco router going through its machinations here to, and I'm hoping that it does not do this again. If it does, that's okay. We can try. We've got some other things we'll be working on here. All right, so that should allow us to... I'm patiently waiting. Looks like it's not going to be quick enough. So we've got that configured. So now we want to validate, right? Remember, part of the... And there we go. So part of the require... Oh, and it's double typing again now. And it's done this before to me. In another video, it did the exact same thing. So I'm going to, since PC is working here, I'm going to go ahead and add in another statement for 20, which is the PC. We're going to make that sequence number 20 in that ACL. So if I say show IP access list, you can see we've got the following statement. So we've covered the www, the HTTP and HTTPS. You can see for some reason it had 27 matches, although I'm not really generating any traffic. So let's check on the PC here. So now if I were to say trace to 192.168.100.100.1, what we should see is that this traffic should be redirected now auto-magically for us. It should hit the 192.168.110.1 after it ARPs out, which is why we see that first failure there. But now we should see 192.168.110.1. All right on cue. And then we should see 10.10.21, not 10.10.10.1. And there you go. So we're actually forcing the traffic, and I'll leave this in so we can validate it. It's nice to be able to see that. So what I was saying earlier was, if I were to go to the HQ router, this serial 20 interface right here, which is that, where's that serial 20 interface? Right here. That is the 10.10.21. So what would happen if I were to go to privilege exec into global config interface serial 20 and say shut? What's going to happen? Is it going to auto-magically reroute off of the branch 1 router? And so let's take a look. And it might be, I didn't see an EIGRP message there. I don't believe we're running EIGRP on that link. We'll have to see here. So we'll give it a second. But it doesn't look like... And so we got the first hop there, and then take a look at what's happening now. So as you can see, the traffic is being dropped. And the reason the traffic's being dropped is because policy-based routing is static. And this is what I meant when we talked in class, is that PBR, and you can see then it ended up going to 10.10.10.1. So, but let's make sure, let's see if, and I want to check to see if maybe it reconverts. I wasn't sure if, I don't believe we're running EIGRP there. Let's say do show run section EIGRP. And it is, EIGRP is running there. So a better interface to have shut down. Let's see where we ended up here. So this may have auto-magically rerouted, and it did. So a better interface to have shut down. So I'll say no shut. Would actually be that 192.168.100.1. So if I were to say do show IP interface brief, and let's come over to the PC here, and I'm going to start up not an extended ping, but a we'll say ping 192.168.100.1, and I'll repeat this, and we'll just do it 500 times. So as you can see, it's off and running, right? We've got connectivity, but if I go into interface Ethernet 01 and I say shut, and we came, those 500 went pretty quick there. You can see now that it's unreachable. And even if we were to wait, what we would see is there's nothing here that can confirm that network is up, or that the next hop is available, but that was because it was going through the EIGRP reconverged. However, you can see here that the PC can't reach it because the interface is down, and so it's down hard. And again, PBR is static, and this actually, when we were in the other video, worked. We were going to the northbound path, but I'll bring this interface back up. But even without PBR, this would break it, right? And then we come back to the PC, and you can see that then it completes. So in the previous lab, the way it was working was, I believe it was going over the WAN this way, and it wanted us to send it this way. And so when I took that interface down, there was no EIGRP, I believe, running between these guys here, so there was no way for the protocol to converge. All right. So again, key point is that it is a static setup. So what do we need to do? Well, we want to set up IP SLA to make sure that it is keeping an eye on basically our connectivity across the WAN. So here's what we're going to do. So we're going to say IP SLA 1, and we're just going to use the ICMP echo. You'll notice that this is a very popular one throughout the course. So 1010, and verify reachability of the neighbor. Let's see here. So it's going to be, let's get up the job A's. So we want to verify reachability of the neighboring WAN interface. And I'm not sure, and I guess that may be right. So it's going to be coming across the WAN. That would be 10.10.10. And that's interesting. Let me check and see here why they want us to monitor, because that doesn't make much sense. Let's see. Let me reread the scenario. EIGRP is configured between HQ and branch 1. Okay, so by default, all traffic flows over the Ethernet WAN link. You need to redirect web traffic over the serial link. Furthermore, all traffic from the notebook. Ah, here we go. Read right by it. So all traffic from the notebook should go via branch 2. But you need to make sure that branch 2 is available. All right, so all traffic, and that's interesting, from the notebook should go to branch 2, yet they only had us do the statement for www. So, okay, so it looks like we're going to have two statements here. Or two route maps, I should say, not two statements. Two ACLs, and how are they going to set that up? So the IP policy that we have, so this is interesting. So we can only have one route, whoops, lost our connection there. We can only have one route map. There's only one IP policy statement, that we can apply per interface, right? So if I say do show run interface, and what interface is that in there? Ethernet 02? Yeah, I believe it's 02. Ethernet 02. You see we have that IP policy route map. So they want us to match. All right, so here's what we're going to have to do. So let me exit out here before we get into the IP SLA. And let's say do show run include, or actually do show IP access list. And there's our ACL. So here's what I'm going to do. I'm going to yank out IP access list extended, www, and I'm going to say no 15. So we're going to pull the permit IP host entry in there for the 110.10, which is the notebook. And I'm going to leave the PC in there, and let's put the notebook at, actually I guess we could leave the notebook, or no, we don't want to leave the notebook in there. So here's what we're going to do. So let's exit out. I'm going to say IP access list. We're going to do one route map. I'm going to put a second statement in the route map, permit 20. So I'm going to say IP access list, and this is going to be, extended, and I'm going to call it notebook. Right, and we're going to say 5 permit IP IP host 192.168.110.20 or no, 110.10 to anywhere. And then let's say do show run, and let's take a look at our route map. Or sorry, do show route map. Let's take a look at that route map. So we've got a single clause in there. So here's what we're going to do. We're going to say route map rm underscore www permit 20. And we're going to match IP address. And remember, I created a new ACL called notebook, and then I'm going to set IP next hop, and they want that to go here. So Ethernet 00 on branch 2. So let's go ahead and say show IP interface brief 10.10.32, and that would definitely be the next hop. So set IP next hop 10.10.30.2. And now if I say do show route map, we have two statements or two sequences in the single route map rmwww. The first one is going to be matching that www ACL. The second one is going to be matching the notebook. Now you can see that we had a ton of matches here, right? And we've got bytes that are flowing through. No matches yet here. Let's generate some traffic off of the PC by saying let's trace to 192.168.110.20. And yeah, this was a little interesting because we definitely need that second statement in the route map. And let's let this run here for a second. And it only made it. Oh, I apologize. I traced to myself 192.168.100.1. As I was watching that, I'm like, where am I going here? So I actually traced to myself by accident there. I apologize. So now we're going to the segment that's over behind router, or the HQ router. So I should go to 192.168.110.1. And then, because we've set the next hop, I should go to 10.10.32, because that's my next hop. And so it shows that we're going to 10.10.21. And is that, let's make sure that that is not what I set. No, for that route map, it should be going to 10.10. So it's getting matched there. Let's take a look at that show IP access list www do show. Aha! So I pulled out the wrong entry here. So let's get the right entry pulled out of here. So let's say IP access list extended www. We're going to say no 20, and then I'm going to say 15 permit IP host 192.168.110.10 any. And let's fix that real quick. I apologize there. All right. So now if I say do show IP access list www, there we go. So, and what just happened there was the first route map statement, the first sequence number 10, was matching on the PC, and we want it to match on the notebook. So now from the PC again, let's rerun that, and we're going to see that it's going to go to 10.10.32, and then make its way down to the HQ router. So we'll give it a second here. And again, the first hop will be the same. It's the only exit point. It's a default gateway for the PC in the notebook, 110.1, and there it is. And now our next hop should be to 10.10.30, and it is jumping to 10.10.10.1 for some reason. Let's see here. So if I were to take a look again back on show IP interface brief, let's make sure we've got the right IP. I do. And do show IP access list. And we call the last one notebook. And and so it's matching 10. I apologize. I'm falling apart here on the ACLs. I got the IPs backwards, and it has caused all kinds of issues, as you can see. But this is good, right? Opportunity to go back in, do some troubleshooting. So let's say IP access list extended notebook, and I'm going to say no 5, and then 5 is going to be permit IP host 192.168.110.20 any. All right, so we should be sorted out now. So this will be our last trace route here, and this one I am convinced is going to do the trick. I apologize there. I got the PC and the notebook flip-flopped and caused all kinds of issues. But again, I like to call these fortuitous failures, right? It's an opportunity to go back, get a little extra time, a little extra drive time, and to have to troubleshoot things. So let's see if we make our hop to 10.10.32, which is what we set that next hop to. There we go. All right, so we made it to 10.10.32, and then we should hit the HQ router, and I'm not sure of the IP on that side, so 10.10.41, and then that should complete things. So a better example of why policy-based routing is static. So let me go ahead and say ping 192.168.100.1, and I'm going to repeat this a good number of times here. So we're going to let that run. So now, when I set it static, right, we're not running EIGRP. So EIGRP is not running between these interfaces and these interfaces here, right? So are these routers across those interfaces. I believe it's running there and, there and across the WAN. So we can validate that. But let's see what happens on the HQ router if I come in and shut down serial 2.1, right? Because we're not checking to see if there's any reachability there. So if I come in, and in fact, I could probably even take a step back and go to branch 2's Ethernet 00. So let's see what happens if I go into global config and go into interface Ethernet 00 and say shut. So if we come back to the PC, we'll notice that traffic has stopped. Now let's go ahead and give it a second or two here and see if the traffic comes back, if it reconverges. But I don't believe that on branch 2, if I say do show IP EIGRP neighbors, let's see. Yeah, there are no EIGRP neighbors. Do show run section EIGRP. And that router, so the branch 2 router is not running a dynamic routing protocol here. And that's what saved us in that sort of the failed attempt there to show how PBR is static. That's what saved us here, is that they are running EIGRP between HQ and BR, as it said in the scenario. So again, take a look at the PC. Everything was working great. We shut down this interface right here, and the traffic that was flowing this direction is still flowing that direction. The problem is that PBR is not smart enough to say, I could go this way or that way and still get to where I'm trying to go. PBR basically says, you told me with your set IP next hop, whoops, sorry, drove off the screen there. With the set IP next hop, you told me to go to 10.10.32. And that's what I'm going to do until I'm told to do otherwise. And so that's the behavior that we see right now. So again, back on the PC, it's not going to there's going to be no reconvergence here. The traffic is going to black hole, even though I have 2 additional pathways to reach my destination. Now, this is obviously not what we want. So let me come back to branch 2 here, and let's go ahead and say no shut. If I come back to the PC now, take a look at that. Right? So that interface comes back up, and PBR is still sending the traffic there. So as soon as the interface comes back up, the traffic begins to flow again. So we'll let that continue on. And now let's come down to branches. So now this is going to sort of wrap things up here. We're going to put a bow on it, so to speak. So we've matched the web traffic. We have created the route map. We've matched the notebooks traffic. We have the notebook traffic now taking the northbound path. So what we want to do now is we want to create an IP SLA using ICMP Echo to test the reachability of the 101032. So that next hop IP that we're telling the notebook to send its traffic to. Because if that's not available, then what we want is we want the traffic to then go across another interface, right? To do what it would normally do. All right, so here's how we're going to do that. So IPSLA it seems a little confusing at times, right? Because there's a number of steps involved. So if you break it down into smaller steps, so the first thing we're going to do is we're going to create the SLA, and we're going to go ahead and say IPSLA. We're going to give it an entry number. So we'll just say IPSLA 1. Now we want to define, ICMP Echo. We want to define, and actually let me back up to a question mark here. You can see there's quite a few things that we can choose, but ICMP Echo is a very popular one because, again, we're just going to be pinging to see, is that next hop available? And so who are we pinging? So what comes next is, what are we going to ping? So 101032. And this is going to be the IPSLA responder. And then it's going to be from who, right? So I usually like to use source interface, and so we know that the source interface is, what was it, Ethernet 10, is that right? Yeah, that looks right. So let me double check that, because that does not sound right. Do show IP interface, do show IP interface brief, and yeah, it is not Ethernet 10. So it's actually mislabeled there on the lab. It's Ethernet 01. So again, ICMP Echo 101032, and that's the destination, and then the source interface is going to be Ethernet 01. And that's going to allow us to ping out our Ethernet 01 from the branch 1 router to the 101032. Now, I have to pick how often do I want this to happen. So I'll say frequency every 5 seconds. Again, frequency is time in seconds, so I'll say frequency time is 5. Then we exit out. So we've defined the SLA, we've defined the type of SLA it's going to be, the ICMP Echo, and the frequency that it's going to take place, so every 5 seconds. Now let's schedule it to start. So IP SLA scheduler, or schedule, the entry number will stick with 1. So my start time will be now, and the lifetime will be forever. Okay, so now we've got the SLA created. We've got the schedule for the SLA, how often it runs, that's created. Now we need to do the enhanced object tracking, right? So we're going to create a tracking object. So I'm simply going to say track 1 IP SLA 1. Now, I could say track, and if I do a question mark here, it's the tracked object, right? So track 1 IP SLA 1. So we're tracking IP SLA 1 with track object 1. If I were to say track 99 IP SLA 1, I could say that as well. In fact, let's take a look at what that looks like. So we've got that set. So now, the last thing that we need to do, or one of the last things that we need to do, is we're going to have to change our route map statement that we created there. That permit 20 statement is going to have to change And so let me say do show run begin route map. Let's take a look here at the route map. Oh, so it shows the IP policy. All right, we hit the IP policy, but we'll get to the route map soon enough. So here we go. So route map www, permit 10, permit 20. So here's the key, right? With the IP SLA, when we're using IP SLA with PBR, and remember that IP SLA is useful with static routes, not the dynamic routing protocols, as we saw actually when I tried to demonstrate the static nature of PBR. The dynamic routing protocols, those will reconverge, and traffic will then continue to flow. So IP SLA is not, at least with ICMP Echo, doesn't really, it's not a good use case if you've got a dynamic routing protocol, because the routing protocol is going to take care of it auto-magically for you. However, with static routing and with PBR, it's a great idea to use IP SLA, especially when there's no dynamic routing protocol to give you an assist. So we're going to have to change this last statement here, because we want to make sure when we're using IP SLA tracking, right, we have to include, or we want to include, the verify availability keyword to make sure that it's checking the tracked object, right? So it's checking the tracked object, which in this case is going to be the ICMP Echo, to see is everything okay. Because, and this is very important, and let me go ahead and let's put that in here first. So I'm going to go ahead and say, where are we at here? So we'll say route map rm underscore www permit 20, and I'm going to say no match IP address notebook. And actually, no, we'll leave that. We're going to say no set. So let me say no set IP next hop to 10.10.30.2. I'm going to say set IP next hop, and this is where we want to make sure we put in verify availability of the 10, oops, sorry, not the 19, 10.10.30, boy, oh boy, 30.2, and what's the sequence to insert in the next hop list? It's going to be 1, and we're going to track. And what is my tracked object? Well, we used track 99. All right, so let's take a look at this route map again. We'll say do show run and burn through the config here. So did we get it right? So we've got the permit 20 statement, match the notebook and the ACL, set IP next hop, verify availability, 10.10.32, and we're doing a track 99. So let's go ahead and let's, on the PC here, and you can see traffic is flowing wonderfully, right? If I go to branch 2 and we say shut again, let's come back to the PC, and the object tracking, remember we said, I believe, every 5 seconds, and there you go. So it checked, and within 5 seconds, if it didn't have reachability back, it started, it would send it out the path it would normally go without the set IP next hop statement. And so we're going to talk about that here in a second. So let me come back to branch 2, because what happens if I say no shut? And I've brought that interface back up. Does traffic continue to flow without fail, or do we drop a few packets when we go to transition back to the other interface? And as you can see here, the behavior is it's not dropping any traffic at all. It kind of slowed down a little bit, but it's not dropping any traffic at all. So let's go ahead and pull up our validation real quick, and let's take a look at some of the things that we're going to walk through here. And all right, this is going to become a little problematic. I'll slide this over. All right, so verify that the route map is defined, and that's going to squeeze it. All right, there we go. Okay, much better. All right, verify that the route map is defined. So on branch 1, again, we've already seen this. If I were to say do show route map, so there is our route map. The access list that it's working with is www, as well as, that's in sequence number 10. Sequence 20, it's working with notebook. And you can actually see we have a ton of policy matches, right? And policy matches, we've got a bunch of them here as well. So that looks good. The route map we already defined, so if I were to simply say do show run interface Ethernet 02, there's the IP policy route map. So everything looks great there. Now let's take a look at the IP SLA. So I'm going to say do show IP SLA summary, and there we go. So we've got IP SLA 1. What type of IP SLA is it? It's using ICMP echo. That's my destination, so that is what I am pinging. My round trip time right now is 1 millisecond. Return of the last attempt was okay, and that is what we want. If I come back to branch 2 and I say shut, remember we've got these pings going. Look what happened. Now remember, it's going to check every 5 seconds, so we should be back online in 1 or 2 periods, and there we go. So now it's fallen back to the path it would have taken had we not been using policy-based routing. So now, instead of going this direction, and this is what the IP SLA is all about, PBR says go this way. This is what PBR says. As soon as that link went down, when I shut it down, IP SLA then kicks in, and it waits, because we're only sending an ICMP echo every 5 seconds. So within 5 seconds, we get a status code back that says either OK or we've got an issue. And if we have an issue, it just simply says I'm sending it. And actually, I don't think that was the original path there. The original path, I believe, was this way. So, but the key point here is it's going to send it back over the original path. The path that it would have routed it had there been no PBR setting the next hop to come this way. And again, that's the big difference with IP SLA, Enhanced Object Tracking. It allows us to make PBR dynamic, right? So again, the use case is we've got no dynamic routing protocol, we're using PBR, and we want it to act dynamic, right? And so that's where we pull in IP SLA. So let me clear the screen here, and we'll come back to branch 2. Actually, what the notebook, who's doing the pings here? Was it the notebook? I'm sorry, the PC is doing the pings. So as you can see, this PC is still pinging away. So now back on branch 1, let's rerun this show IP. Sorry about that. Let's rerun, and I like this, right? We get a message here, syslog message, tracking 5 state, or the enhanced object that we're tracking, number 99, which is tracking IP SLA 1. The state went from up to down. So let's see, what does do show IP SLA summary show now? Timeout, right? The return code is now timeout. We've got no stats because it is down. So let's bring it back up here. So we'll simply say no shut. Traffic continues to flow. And let's see, it's in timeout. So it should start back up here when the interface comes back up every 5 seconds. I shouldn't say it starts back up. It's running nonstop, the IP SLA. When the interface comes back up, one of the next, and there we go. And there's the return status code. The return code is now flipped back to OK, and there we go. Tracking 5 state for enhanced object tracking number 99, who's tracking IP SLA 1. The state has now gone from down to up. The return code is OK. So what if we say do show track? All right, so what do we have here? We've got the IP SLA state. The state is up. It would have said down. That was the message we saw here, right? And specifically right there, down to up. That's why it says up. It would say down if I shut that interface down again. We've had 5 changes. Latest operation return code is OK. Round trip time 1 millisecond. And what is it tracked by? It's tracked by a route map, right? And that's where it's being referenced, is in the route map. So let me go ahead and we'll scroll down a little further. So now on the notebook, we should see, and let's make sure we've got this working here. So we're going to say trace 192.168.100.1. And the notebook, and I may have this backwards actually. I think it's the PC. So let's do Control-Shift-6 here. And let's do a trace to 192.168.100.1. Make sure, I'll do it on both to cover my bases. Because we had the issue before where I got the IPs mixed up in the ACLs, and then we were going in different directions. So it says the notebook, but let me check, because I think we may have set this for not the notebook, but for the PC, the 192.168.110.20. So we make the first hop is correct, and then we go to 10.10.32, which is beautiful, right? Our set IP next hop is working like a champ, and then it should take us down to 10.10.41, and then that's it, right? All right. Well, this wraps up, and let me go ahead on branch 1. I'm going to show you my branch 1, my final config here. So we'll say end show run. I'll see if I can get it into the one screenshot view here for you. So here it is. So there is the extended access list for the notebook, the extended ACL for the web traffic that we were matching. Again, we had to mix it up a little bit because the way they described it, it really wasn't clear. Do we get just HTTP, or do we get HTTPS as well? And then even worse, there was really no way for us to validate that, at least not that I know of. So I threw the IP host, the permit IP host, for both the PC and the notebook into their respective ACLs so that we could do some validation work there. We've got our IP SLA statement here, which defines the IP SLA number, what kind of IP SLA it's going to be, and how frequently it takes place. So that was kind of step number 1. Step number 2 was to schedule the SLA. And then step number 3 was to go ahead and create the tracking object, which is further up there. We went by it earlier on. And then last but not least, when we're using IP SLA, we want to make sure we've got verify availability, right? We must have the verify availability in there, or else we are not going to get this to function. The enhanced enhanced tracking object is not going to do what we think it's going to do. All right, well, this wraps up definitely a grueling PBR IP SLA challenge. Again, another awesome activity here from the Cisco Learning Labs. So I thank you guys for watching, and I will see you on Monday night.